Good morning, good afternoon, good evening, depending on where you are. I'm Puneet Shetty, as Ozer mentioned, Head Product Management for Celona. Thanks, Ozer, for that lovely introduction and putting forth the questions that will help us structure our discussion today. So let's jump to the first one. Can we treat campus network as software? And I think if you think about it today, the answer is a resounding no. The campus network operating systems that we are familiar with have always been thought about as these monoliths that are fairly static in nature and have not really kept pace with applications. And the applications themselves are actually moving in exactly the opposite direction. They are getting more and more dynamic. They're getting more and more dispersed. And that is giving enterprises an opportunity to spin up compute as they see necessary, deploy applications based on where the users are and where the actual need is and when the need is. These compute infrastructures could be edge compute infrastructures from AWS Snow family to private stack edge from Azure, or they could be metro edge or regional hubs such as AWS Outpost or private edge zones, or our very good old public cloud and enterprise data centers. So in essence, enterprises today have the ability to have compute available everywhere because of all of these different options. And they have the ability to also deploy applications in each of these different locations as the need arises. And when we put that back into the networks, the campus networks that are supporting these applications and these devices, what we have seen is that particular flexibility and dynamism is not available. But with 5G, that is changing, right? So the way private 5G or the way 5G itself has been defined, it's taken into consideration the underlying cloud native and software-defined principles. So what that really means is every network function, be it a core function, be it a radio function, all of this has been defined in the 5G spec, ground up as a microservice. And there are very clear interfaces between these microservices that have also been defined. And what that allows for a solution provider like Celona is to build our architecture by imbibing these principles from day one into our architecture. And that allows enterprises to now think of their private mobile networks as they would think of their applications, right? They could now deploy these network operating systems, the Celona Edge, on a compute infrastructure of their choice. They could use the same orchestration tools that they use for applications for this particular network function. And hell, they could actually deploy the network function right alongside the application on the same edge compute infrastructure and box. And that's very, very powerful. And in essence, the definition of edge and the definition of compute is becoming more and more diffused and becoming more and more spread out as we see it. And hence, we have tried to capture that with the term edgeless enterprise architecture. So breaking these network functions into microservices lends the same advantages as it did for applications. When applications were monoliths and they were split up into these different microservices, what it did was it allowed the developers to think of scope it down to each individual microservice and what that microservice did as a function. It allowed them to deploy these microservices independently without affecting the overall system. And that really accelerated the feature velocity and in the end improved the end user experience that the application users were seeing. The same advantages now are available for network functions as they are being built upon the same principles. And by design, this particular architecture improves portability, it improves scalability and availability, things that we have now come to expect from cloud native applications. An example of this is, let's say you have a campus network and there's a sudden surge in traffic. There's a sudden surge in the number of users that come onto the network. Maybe there is an event that's happening, or maybe a new application, a popular application has been introduced into the enterprise. Now you have the ability to take a specific microservice like a data path or a data plane microservice, scale that up and down based on what the need of the enterprise is, based on what the need of the users are, and do that in a dynamic fashion, and track that in an intelligent way, and use the resources appropriately that are available to you. So if I ask the question again that Ozer put forward to us, hey, can we think of campus networks as software? Hopefully with what we have talked about so far, the answer is changing from a resounding no to a maybe or a yes. And what does that do to an enterprise and the enterprise network teams? It now gives them the ability to think of their network services as applications. So they don't have to think about static configurations, but more dynamic orchestration. This lends itself to automation at all the levels, and hence reduces the time that they end up spending on troubleshooting. One can now take application intent, application SLAs that you expect, and translate that into network resources, and do that in a dynamic fashion with the compute resources that are available to you, using the same orchestration tools that are available to you. And all of this should move network operations from the day-to-day firefighting to more focusing on application-specific KPIs and driving towards application SLAs that they are signing up for, because that's what drives the bottom line for the enterprise. And given this, the campus network do not have to be the bottleneck for enterprise innovation and digitization.
How do you deal with the hardware and the access points? Because that's still like a very hardware component, and that's still like in the wireless, that's still something we have to deal with and kind of design, so we make sure we have sufficient coverage and guarantee the lower layer 1, layer 2. So how does that fit to your software vision of seeing the network?
Yeah, so you're right. So a lot of the things that we are talking about is from the perspective of the mobile core, and how we can actually move the mobile core closer to the application to deliver, let's say if you want to deliver low latency for specific applications, and being able to do that in a fluid and dynamic manner. That's what the focus is of this discussion. But even on the radio side, what we are seeing with 5G, Francois, is that they are actually splitting up the RAN functions into individual functions and into different layers. And there are different options available from a deployment perspective that allows this kind of flexibility even at the radio level. But you're right, when it comes to coverage, there is limitation as to, okay, where you're deploying the radios and what kind of users are actually able to attach to the network. But on the core side, you now have the flexibility because of this cloud native architecture to really scale up and down as needed.
Thank you.
Perfect. So one of the key ingredients of actually us being able to deliver on this promise of edgeless enterprise architecture and a programmable network is building a platform that is API first. And that's what we have done with our platform. So when it comes to the Celona Orchestrator, we have everything that you actually will see and what you'll see Mark do on the orchestrator is available via APIs, whether it's management or configuration APIs. We're also able to, on the inbound side, pull data from all of our components, but also we are working towards pulling additional data sources in the form of applications and other enterprise systems so that we can take all of these different data sources and correlate them and provide richer insights to the enterprise. On the outbound side, all of these insights are available via different modes, whether it's polling methods, whether it is generic webhooks, and we are adding other layers as well. But from a developer perspective, whether the developer is coming in from an enterprise trying to build network operation dashboards, whether they're coming in from the ecosystem, device, application, trying to use the power of this programmable network to deliver the application SLA, the goal is to serve all of those different developer personas. And later today, after the presentation, we would love for all of you to actually have access to the demo environment that Mark is actually showing. And we would love for all of you to look at the orchestrator, play around with it, and also get access to the API libraries that we have made available. And would love to kind of get some feedback on that. So that's something that we will share with you at the end of the presentation.
Hey, a quick question.
Sure.
When using this, are you following the ETSI mobile edge computing standards in terms of how they're integrating it into the 5G networks?
So from our perspective, we have chosen the underlying the microservices principles to be, it's Kubernetes-based microservices architecture that we have picked, right? And so each of the it's generic enough that it could be orchestrated using any of the underlying orchestration layers that these individual systems might bring to the fore. So from our perspective, we are not necessarily tied to any specific implementation or standard, but from a 5G perspective and all the individual functions that are defined for 5G and the interfaces that are defined that allow these functions to talk to each other, those are 3GPP and 5G based. But as far as the orchestration of these functions are concerned, we are using a generic framework for that.
Okay, so the ETSI orchestration interfaces, which I forget the interface reference points, is like MN or something like that. I can't remember them all now. But you're saying you don't follow those particular standards and guidelines, right? You've developed your own, right?
No, we have developed a generic framework that should be able to fit into the ETSI guidelines. But from a 5G functions and 3GPP specification, we definitely follow that. But from an orchestration perspective, it's a generic enough framework that should be able to fit into the ETSI framework that you're talking about.
Okay, thank you.
Yeah.